Hello. We are the OmniByte group. I'm Nick.
I'm Evan, Mitch, and Ethan.
Our sponsors are Brian, Billy, and Jordan. So a little bit about OmniByte. They're a local company founded in 2015. They're located just north of campus. They primarily focus in commercial and residential field services, making web portals, apps, and stuff. One of their main things is the Forms Pro, which you can take or just easy to use and make forms, and you can email it to your customers. That brings us to a problem. So the Forms Pro has the ability to capture information using many different questions like check boxes, radio buttons, text fields. So the more time that can be saved, more time that can be saved, we could reduce that effort by take a picture and get the information from there. So brings us to our solution. So we're gonna we built a sample app using Ionic and Angular, and we had to research and understand what OCR SDKs are available, and so it can scan an image and recognize the text and the numeric values and populate it in a form.
Alright, sprints. Are you gonna take this? Alright, yeah. Our sprints were broken up mostly into 2 or 3 weeks throughout the year, or the semester, I should say. Our first sprint, we mostly focused on getting the base down, going through Ionic tutorials, looking up all the different OCR software we can use, doing all the documentation. So most of this was spent not so much fulfilling user stories, but just understanding all the stuff that we need to get together to get our app started. And then we had found, after a couple of weeks, an OCR service to use. At this point, we had the app where you can take a picture, you can save it to the phone, and you can send the picture to OCR Space, which is an online service that will do OCR for you. This was not the ideal solution because OCR Space just gave us back plain text and did not work with handwritten text. And that's what we dealt with in Sprint 3. At this point, we could get the text from the image and put it in just a single field in a quick sample form in the app. Handwriting was still not working, especially with OCR Space. So to try to find a way to get that to work, we switched to Microsoft's OCR computer vision that works with Azure, which OmniByte has some ties with. So we could get that without it breaking the bank. And that improved a lot of things. So we went from having just plain text to having all the words that are scanned in split into regions and lines and words, and each thing has its own coordinates, which gives us a lot more to work with when trying to do the automatic selection as opposed to manual. And then in this last sprint, we had planned on also adding in gauges and dials. So if you remember midterm presentation, I explained how on the clock we would get where the second hand would be, and if that was overlapping some data point in there, if it was overlapping the 9, we'd know that would be at 9 o'clock. We didn't get to that. That may be a whole project in and of itself. Most of our time was spent just trying to get the OCR to work and finding stuff that works with Ionic. And where we are at now, and we will be demoing it to you soon, is getting text from the image and letting the user manually select which goes in, as well as some very basic automatic selection that was recently implemented.
Okay. So for our current status, we have the printed text working with the taking an image of a form. We've been trying to implement handwritten text into this app. It's a little different process than doing printed text because it doesn't send off a response when we have to retrieve it, and working with Angular and Ionic, it was a little bit tricky to figure out how to get that information back. We do have the manual selection of text that works to put the forms in when you take the photo And as Evan was saying, we do have basic automatic selection that Ethan was working on, and cleaned up the UI, and the form data can now be sent to others via email.
Okay, so switch over for the demo.
Oh boy.
There we go.
Okay.
Yay.
All right. So load up the OCR app. It's visible. Zoom in a bit here.
Does it look okay? A little muddy. Yeah, did you hit autofocus?
Yeah. Okay. It's got the splash screen, basic form setup here, and the actual image analysis right here. So to demo it, I'll capture an image for our first example. So we just have a really basic sample form where the data we want is to the right. Rotate that. Try to get a better prompt there. Okay. Send it HTTP colon, we got the response. Then if we switch over to the form, so we can pull it up manually, and you can actually specify data that you want in the form, but we don't want that. We actually want it to auto add it to the form. Then I'll throw another example up, and this is where it kind of got a little tricky because the way the Azure service works is, like Evan was saying earlier, it captures it in regions, lines, and words. So when you get data like this where it's separated by lines or when there's too much separation, each of these have their own individual region. So we needed another algorithm or method to capture the values when they're below the labels. So just capture this quick. Rotate that. Second. Okay, we navigate back to the form, refresh the data in there, and this time I'm going to switch this on because we have the data below the labels we need. I'll update all that. Then we just wanted to, this will go in the message body of the email. So I'll just say hello. And it's integrated with whatever your email app is on your phone. So I'll just send it to myself and we can show that it worked after the demo is over. Send that off. Then one example where we were still having issues on, I'll just demo it really fast, is when you have data that's separated like this. Initially I was thinking, well, each of these have their own region, so it should still be able to pick up that they're separate. But for whatever reason, if they're aligned in a certain way vertically, it will pick them up as the same region, which will demo what happens when that's the case. So now what will happen is, because it's picking, the way the algorithm works, because it's picking them up in the same region, it finds the name label, but it sees all of the other, I can pull over, it sees all of the other text under the same region. You'll notice it works correctly for the phone auto method. Okay, that's about it for the demo.
Okay, then let's switch over back to the
Okay, I'll continue with the issue slide. So, major issue, the automatic algorithm itself could use improvements or different method of detection. Right now, what it's using is it's analyzing each region, and then when it picks up on each line, when it picks up a detection word like name or address or phone number, it's then pulling that data into the form. But if we had more time, a better way would actually be using, so when it returns the data, it has a coordinate system, X and Y, and the box surrounding it. So ideally, we'd probably want a solution that would use like proximity and all of that. But and then another issue would be detecting handwritten text. It usually doesn't work at all, and when it does work, it comes out as pretty garbled.
to go on with that, I had a test page up. It was using part of the Cognitive Services API, and with the mode as written or handwritten, it would detect very good handwritten text. The implementation with the Ionic and Angular was difficult to combine with.
Final issue we have, some of the important features weren't completed until the final sprint. So up until the final sprint, we pretty much just had the detection of text and pulling that into a basic form manually at a very basic level. So we added a lot of it during the final sprint.
Most of our time was spent just trying to find OCR that worked with Ionic, and that's kind of, I think maybe on the next slide even it says, yeah, we wish we would have done a bit more, maybe not a bit more research, but tried a bit more things, because we started just trying to use like Google Tesseract and Google Cloud Vision, and being really set on getting those to work, because they sounded like the things that would do everything that we wanted to do, but they just were not working. Like with Tesseract, the issue was it would just load forever, not give any error messages, and we were stuck on that for weeks. So something I think we wish we would have done sooner is switch to computer vision, or at least done other research to get stuff. Those who have more time at least to get to the gauges and dials, as opposed to having spent like 3 out of 4 sprints just getting OCR to work at all.
And we were divided between, we were trying to get an offline solution to work too, and that never panned out.
Yep.
So next steps for a future continuation of the project, we'd like to develop functionality for reading gauges and dials. That was a goal that was talked about at the beginning. We never got to that. Handwriting recognition. We know it works. We just need to implement it in the app and be able to call the data and everything correctly. We would like to be able to use dynamic forms. That would have been nice, and be able to easily autofill those forms and not rely so much on the user knowing what works. And rework the UI and the front end interface to fit better with Forms Pro. Does anyone have any questions?
I guess one thing, you kind of have the ability for it to auto-detect each field individually. Did you consider just adding one button that says try auto-detect all of
Yeah,
them so I don't
maybe.
have to click?
The UI needs needs a
Yeah,
bit more work.
yeah, that would have been ideal.
I guess so, yeah.
Did you have, like maybe the most used form from the app and try to work with something like that as opposed to a random form?
Did you try to make those example forms sort of mimic the example we got from Billy?
Yeah, like it would work with the manual detection, the auto detection, trying to get that work with a more complicated form. Obviously, that's not like a real world, forms can get really complicated, and the algorithm or the stuff that we were trying just wasn't working for the auto text detection with anything too complicated. So that would go into, if we had more time, we would like to implement it better, and so it could be used more in like a real world scenario.
Thank you.